Hello friends, this video on aldehyde ketone carboxylic acid part 24 is brought to you by examfear.com. No more fear from exam. So after studying aldehydes and ketones, let's start with carboxylic acids. So what are carboxylic acids? So carboxylic acids are the carbon compounds which have this carboxyl function group, that is COOH. This is called a carboxyl function group, COOH. This is a carboxylic acid. If you see, this is the structure RCOH, right? So they have a carbonyl group. This is a carbonyl group here, and this carbonyl group is attached to one hydroxy group, and this is carbonyl plus hydroxy is nothing but carboxy, right? Carbonyl plus hydroxyl gives you carboxyl, and that's why the name carboxyl comes. And this R can be aliphatic or aromatic. So if it is an aliphatic straight chain, then it is a aliphatic carboxyl group or an aliphatic carboxylic acid. If it is aromatic, it is aromatic carboxylic acid. So it can be aromatic or aliphatic carboxylic acid, correct? And large number of carboxylic acids are found in nature, and we'll discuss why they are properly called by their common names. We'll discuss in the next slides, but just understand that there are large number of carboxylic acids, they are found in the nature, right? And some higher members of this aliphatic carboxylic acids are called fatty acid, and they occur as a natural fat, esters, glycerols. So if you see, a lot of these occurs at nature, they are all natural, right? And these carboxylic acids, since they are found in nature naturally, they act as starting material for other organic compounds, for example anhydrides, ester, acid chlorides, amides. So these carboxylic acids, since they are abundant in nature, they act as the starting material for other organic compounds. So if you see, if we talk about the common names of carboxylic acids, please note I'm talking about the common name, not about IUPAC's name at this point of time. So since I told this carboxylic acids exist a lot in nature, and they are among the earliest organic compounds which are known to chemists, a large number of them are called by their common names because they were one of the earliest organic compounds known to human or known to chemists. So their large number of them are called by their common names, and typically IC is the suffix used, and most of them are derived from the Latin or Greek names. So if you see, for example, this is formic acid, SCOH. It was first derived from red ants, and formica means ant in Latin. So it is called formic acid, correct? So if you see, the formic acid was first derived or obtained from ants. So it's called formic acid. Why formic? Because formica means ant in Latin. Similarly, acetic acid CS3COH, it is derived from vinegar. And vinegar, what you call vinegar in Latin is acetum. Acetum is what you call vinegar in Latin. So it's called acetic acid. Why? Because acetum means vinegar in Latin, and it was first derived from vinegar or acetum. So it is called acetic acid. Similarly, butyric acid, it is first derived from rancid butter, and butyrum means butter in Latin, so it's called butyric acid, correct? Rancid butter, Latin name is butyrum, so it's called butyric acid. Let's talk about the IUPAC name now, right? So for IUPAC name writes aliphatic carboxylic acids by name are named by replacing this EE with OE. So as I told, most of the IUPAC name is derived from the alkanes. So just replace E with OE. For example, methane, replace E with OE, becomes methanoic acid. OIC acid actually. Not OIC acid. Methane becomes methanoic acid, ethane becomes ethanoic acid, propane becomes propanoic acid, and the list continues. Correct? Just take the methane from which it is derived, replace E with OIC acid, and you get the acetic or carboxylic acids IUPAC name. And again, the numbering of the carbon chain, the carboxylic carbon is number 1, similar to aldehydes. And for naming the compound with more than one carboxyl groups, the E of the alkane is retained. We'll take some examples where we'll show you that the E is retained there. For example, I'll give you now only HCOH, and I have COH here once again. So if you see here, this is ethane dioic acid, right? So the name of this compound is ethane dioic acid. So you see this E is retained here. But if you talk about HCOH, it is methanoic acid. So E is gone here, right? E is gone from here. But if it has more than one carboxyl group, then E of the alkane is retained. We'll take some more examples. And depending on the number of carboxyl we use, di, tri, for example, in this case we use dioic acid, correct? And the position of COH is indicated by Arabic numericals. And what is this? We just use the normal numerals actually. We just numerals 1, 2, 3. We use the normal numerals for this. Let's take some examples. For example, HCOOH. Let me draw this. HCOOH. So if you see here, this is derived from what? Methane. So it will be methane. Remove E and say oic acid. So methanoic acid will be the IUPAC name for this. If you want the common name, this is derived from formica. Formica, ant means formica initially by chemists, so it is called formic acid. The next is CH3COH. So CH3COOH is derived from ethane. So ethane, remove E and add oic acid, this becomes ethanoic acid, and that is my IUPAC name. If you want to write the common name, it is derived from acetic. It's called acetic acid. Initially, it's my common name. The next is CH3CH2COOH. It is derived from with propane. So write this propane, remove this E and make it oic acid. This is propanoic acid. This is my IUPAC name. Similarly, for common name, this is derived from propion. This is propionic acid. See, for common name, there is not much logic if you remember it. This is propionic acid. The next set is I have CH3CH2COH. 1, 2, 3 carbon, and fourth has COH. So if you see methylprobute, right, it is derived from butane. So butane, move E, make it OIC, butanoic acid. This is my IUPAC name. For common name, it is called butyric acid. This is the common name because it is derived from butter. The next is this guy, 1C. Yeah, this is the compound. We're going to add extra hydrogens. Yeah. So in this case, the IUPAC name will be what? This is the longest chain. Numbering start from here 1, 2, 3. So at 2 I have methyl group, 2 methyl, propanoic acid. This will be the IUPAC name. For common name, this is isobutyric acid. Isobutyric acid. This will be the common name. By iso because it's a branched one. The next is this guy, COH, correct? So this guy, the name of this, it has 2 acidic group. So and it's from ethane with eth. So ethane will not delete E here. Ethane, there are 2-dioic acid. Ethane dioic acid will be the IUPAC name. For common name, it is oxalic acid. This is the common name of this compound. Oxalic acid, please remember, it's a pretty famous acid. We'll take this CH2. Here we have COH. Here we have COH. Again, we have 2 COH and derived from eth pro. So we will use this word propane. Will not delete E. 2, so it dioic acid. That is my IUPAC. For common name, it is called malonic acid. This is my common name. Let's try with this. CH2, CH2, and I have COH. So for this, if you see 2 acidic groups, so 1, 2, 3, 4. 4 is but, so we'll use this word butane first, will not remove E. There are 2, so dioic acid. This will be the IUPAC name. Talk about common name. This is succinic acid. This is the common name. Let's try the third one. CH2, CH2, CH2. Here I have COH and here I have COH. So if you see there are 2 oic acids, so we'll just use this name 1, 2, 3, 4, 5. 5 is pentane. So it will be pentane and 2, so dioic acid. That will be the IUPAC name. Talk about the common name, it is called glutamic acid. Glutamic acid. This is the common name. Let's take some more examples. This one. 1, 2, 3, 4. 4 CH2 we have. And then we have COH. Here we have COH. Since again it has 2 COH groups, so we'll use the same name 1, 2, 3, 4, 5, 6. 6 is hexane. We'll just keep this word E. Dioic acid. And that is my IUPAC name. Talk about the common name, it is adipic acid. This is my common name. Let's take the other one, this guy now. Yeah. So let's draw this. I have CH2, with CH2 I have COH. Then I have CH, I have COH here. And then I have CH2. And then I have again COH here. Correct? So you see there are 3 COH and the number of carbon is 1, 2, 3, 4, 5, but these are extra. So if you see, I will take this only, this much chain, this much chain. It says 1, 2, 3 carbon. So I'll use this propane, and at 1 position, 2 position and 3 position I have carboxylic acid. So 1, 2, 3 try carboxylic acid. This is what we'll do. Please note there is a difference here and here. In this case, we said we took 4 carbon and plus 5 and 6 in 1. So we say hexane dioic acid. But in this case, what I'm doing is I'm taking this chain only, and these 3 are, I'm saying 1, 2, 3 tricarboxylic acid. Right? This is my IUPAC name. And fortunately, there is no common name for this. Such a complex compound. We'll take some more examples. So in this case, we know the common name is for this is benzoic acid. This is pretty common acid. And for this IUPAC name, if you see, it will be benzene carboxylic acid, because benzene is 1 then carboxylic acid. Benzene, carboxylic acid. This is my IUPAC name. But actually, you can still use benzoic acid as IUPAC name because that is accepted. So for this, my common name is phenyl acetic acid. This is my acetic acid, and I have a phenyl there. So it is phenyl acetic acid, and this is my common name. If you talk about the IUPAC name, if you see again this is one position, this is two position. At two position I have a phenyl, so it says 2-phenyl, and this is ethanoic acid. 2-phenyl ethanoic acid is my IUPAC name. Let's take this guy. So this guy has a very good common name, that is phthalate acid. This common name. And for IUPAC name, if you see, again there are two carboxylic acids. You would first take this part, that is benzene, and at two position I have two carboxylic acid, dicarboxylic acid. So benzene 1,2-dicarboxylic acid is the IUPAC name for this compound. We'll do some more. So for this, let's see, this is position 1, 2, 3. At 3 I have a phenyl, so the IUPAC name will be 3-phenyl, and propanoic acid. 3-phenyl propanoic acid. Let's see this guy also. This is my position 1, position 2, position 3, 4 and 5. So at 2 I have a methyl, and 1 I have cyclopentane, right? So it is 2-methyl cyclopentane carboxylic acid. So cyclopentane carboxylic acid was the main one, and at 2 position of that I got a methyl, so it is 2-methyl cyclopentane carboxylic acid. Let's take some more. This is position 1, position 2, position 3, and this is position 4 actually. So this is how it is. We draw this for a clear understanding. 1, 2, 3 and 4. Correct? This is my straight chain. So if you see, at 3 I have a methyl and 2 I have a ene. So it will be 3-methyl, and it is methylprobute 4 bute. At 2 I have ene, 2-enoic acid. This will be the IUPAC name. Correct? At 3 I have a methyl, and 2 I have a ene. If you see, 2 I have a ene, butene. So 3-methyl bute 2-enoic acid. Let's see this. So there are 3 nitro and added to a benzoic acid, right? And if you see, this is my benzoic acid, so it will be number 1, 2, 3, 4, 5, 6. Why? Because the benzoic acid is the primary one, so it should get the least number. So I have a nitro at 2, 4, 6 added to a benzoic acid, so it will be 2, 4, 6 trinitro added to a benzoic acid. That will be the IUPAC. So a benzoic acid, in that at 2, 4 and 6 position I have a nitro group added, so it is 2, 4, 6 trinitro benzoic acid. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.